Hello and welcome to your second set of notes over factoring. Now the notes that you did before, the 7.6 notes, were only factoring when a equals 1. So what do you do if a does not equal 1? Well, then you would use the method that I'm about to show you. Now if a does not equal 1, the first thing you should do is look for a GCF. What is a GCF? A GCF is a greatest common factor. A greatest common factor can be pulled out if there is a common factor in every single term in the function. So for instance, example 1. Example 1 has 4x squared plus 32x plus 60. Well, 4 is in all three terms. So what am I going to do? I'm going to pull it out. And when I pull it out, I'm essentially dividing by that number. But it doesn't equal 0. So you can't just dismiss it, it goes out front. So it would look like this. So I'm going to divide all three terms by 4 because they're all divisible by 4. Well, then I'm going to take that 4 and I'm going to put it out front and write what's left over. Now 4 and 4 cancel to make 1. We get x squared. 32 divided by 4 is 8, and 60 divided by 4 is 15. So that's what we end up with. Now, this particular function is starting with 1 because now we can kind of ignore the 4 until we get to the very end. It will come back, right? It's not going to disappear because in math, things don't just magically disappear, but we are going to go ahead and factor the inside only. So for the inside, we are dealing with 15, and we need it to add, oops, I forgot an x. We need it to add up to 8. So we are going to go and make our table like we did on the last one. We're finding factors of 15. We've got 1, 15, 3, and 5. Well, 3 and 5 add up to make 8, which means our factors are x plus 3, and x, that's a 3, and x plus 5. Now that 4, that was right here, is brought down right there, right? It doesn't disappear, and that's our final answer. Done. Let's do another problem. So first, we need to see if there is a GCF. 3, 7, and 6 have nothing in common except 1. Well, I'm not going to take 1 out, so I'm going to go ahead and use my new method. My new method is called the cross method. The reason it's called the cross method is because you're going to make a little cross, right? A little x underneath your function. So here's how it works. The first thing you're going to do is multiply your a times your c. Well, 3 times negative 6 is negative 18. Okay, now I'm going to set up my problem. That negative 18 is going to go in the top. The middle term, which is negative 7, goes in the bottom. My job, once again, is to find factors of that top number that add to b. The difference now is that instead of just taking c, that last number, we have to multiply c by a to get the number we're multiplying to. So let's make a table of factors of negative 18. And remember, our goal is to add up to negative 7. But just like on that last video, you have to find factors that multiply to negative 18. That means that one of our factors has to be negative. So when we make our list, we've got 1 and 18, 2 and 9, 3 and 6, 6 and 3, 9 and 2, 18 and 1. And because it's multiplying to a negative number, one thing has to be negative, so let's make all of the one side negative. And we need it to add to negative 7. 18 minus 1, that doesn't work. 9 minus 2, that's positive 7. Not quite. 6 minus 3, that's 3. Negative 6 plus 3, that's negative 3. But negative 9 plus 2 is negative 7. So that's what we need. So those factors right here, the negative 9 and the positive 2, are going to go at the bottom of my cross. So I'm going to put negative 9x here and 2x here. Now this works because negative 9 plus 2 is negative 7. Now we're going to work our way around. We're going to start with 3x squared. We go down and we write negative 9x. We go over and write plus 2x. And then we go back up to get to negative 6. Now we're going to group. We're going to group the first two terms and the last two terms and take out GCFs. Now 3x squared and negative 9x both have a 3x in it. If I take 3x out of 3x squared, I'm left with x. If I take 3x out of negative 9x, I'm left with negative 3. I'm going to do the same thing with the second term, or the second two terms, that second group. 2x minus 6 both have 2 in it, so I'm going to take out a positive 2. Don't forget the sign. Then we're left with x minus 3, because 6 divided by 2 is 3. Now, in order for this to work, those insides have to be the same. Because they're the same, that's one of my factors. Now we're going to look at the outside terms, 3x and 2. Well, that's going to be my other one, and I'm just going to take the 3x plus 2 and write it next to each other. So 3x plus 2. That's why that sign is so important. If you don't have a sign there, you might think that they're multiplied, but they're not. They're added, because that's the sign. And that's my answer. Let's do more of that topic. Okay, we're going to do the same thing 4 more times, just to make sure you get the idea. So first, is there a GCF? That's the question. GCF? Well, 2, 7, and 6 don't have anything in common, so the answer is no. So I'm going to jump straight to my cross method. Okay, so let's set this up. We've got the cross. A times C is what we're looking for. 6 times 2 is 12. That goes on top. The middle term goes on the bottom. This time it's positive 7. And we're looking for factors of 12 that add to 7. Well, factors of 12 are 1 and 12, 2 and 6, 3 and 4. Hey, 3 plus 4 is 7. That's what I'm going to use. I'm going to put the 3x on the bottom left and the 4x on the bottom right. It does not matter what order you go in. Either way, you will get the same answer. We start in the top left corner. We put 2x squared. We move down. We put our plus 3x over to plus 4x and back up to plus 6. Here we're grouping again. What can you take out of 2x squared plus 3x? Well, 2x squared and 3x both have x. So I'm going to take out x, and I'm left with 2x plus 3. 4 and 6 both have 2's, so I'm going to take out a positive 2. And we get 2x plus 3. Are the insides the same? Yes, that's one of our factors then. Which means that we're going to take what's outside and write them next to each other. So we get x plus 2. That's the answer. Another one. 4, 7, and 3. Do they have anything in common? Is there a GCF here? The answer is no. 4, 7, and 3 don't have anything in common. So we're going to go ahead and set up our cross method. 4 times 3 is 12. Negative 7 goes on the bottom. Now, factors of 12 that add to a negative number would both have to be negative, because a negative times a negative makes that positive. So we have negative 1, negative 12, negative 2, negative 6, no, negative 3, negative 4. There we go. So I'm going to put negative 3x down here and negative 4x right here. Now I'm going to write things down in that square. So we start with 4x squared. We go down and we put negative 3x. We go over and put negative 4x. Then we go back up and put plus 3. Now we group. First two terms, last two terms. And we're taking out what they have in common. 4x squared minus 3x both have x, so I'm pulling that out, and I'm left with 4x minus 3. Negative 4x and positive 3 don't technically have anything in common, but when it starts with a negative, you're going to pull out the negative. Anytime it starts with a negative, you pull out the negative. Okay, write that down. Starts with a negative, pull out the negative. That means that I can't pull out a number except 1. So I'm going to pull out negative 1. All that's going to do is change both of my signs. So instead of negative 4x, it's positive 4x, and instead of positive 3, it's negative 3. Hey, look, my insides match. They're both 4x minus 3. That makes that one of my terms. Factors. And then the x minus 1 that I pulled out, that becomes my other one. Again. Now, you see how it starts with a negative? Well, I just said if it starts with a negative, take out a negative. So the GCF in this particular problem does exist, and it's a -1. I'm going to take out a negative, and that's going to change all of my signs. So the negative 9x squared becomes positive 9x squared plus 3x minus 2. Changes signs when you take out negatives. So we use our cross method because they don't have anything else in common. -2 times 9 is -18. We need to find factors that add to 3. So, here we go. We've got a list for -18. Factors of -18 that add to 3. Well, we have -1 and 18. Nope. -2 and 9. Nope. -3 and 6. Hey, what's 6 minus 3? 3. Okay, so we have -3x and plus 6x. Now we work our way around. So we start with the top left-hand corner. We have 9x squared. And again, we're still going to just ignore that negative that's on the outside until we get back there at the end. Okay, you go down to -3x. You go over to positive 6x. And then you go back up to -2. Now we group the first two and the last two. From the first two, 9x squared and -3x both have 3x in it, so we're going to take out a 3x. We're left with 3x minus 1. 6x and -2 both have 2 in it, so I'm taking out a positive 2. We're left with 3x minus 1. Inside they're the same, so that is a factor. The outsides give us the other factor. And that's it. Last one. We have 8x squared plus 30xy plus 7y squared. 8, 30, and 7 have nothing in common, so there is no GCF, so we're going to go ahead and multiply a times c. 7 times 8 is 56. We need it to add up to 30, so we make a list. Right, and this one might really require a list. So we have 1 times 56, 2 times 28. Oh, hey, look, 2 and 28 make 30. That was convenient. So we're going to put the 2x here and the 28. Oh, okay. It will be x, but actually, look right here. We get this bottom term, the green term, from the middle. All right, so it's actually not x, it's xy. Because the bottom corners, the letters on the bottom corner should match the middle term's letters, whatever that happens to be. Okay, and you'll see why in a minute. Now we're going to write it all out. So we start in the upper left-hand corner, 8x squared. We go down to 2xy. We go over to 28xy. And we go back up to 7y squared. And we group. Now if I didn't use the middle variables, then this isn't going to work out. That's why it's essential. Okay, because 8x squared plus 2xy have something in common. They both have 2's, and if you look, x squared and xy both have x. So that's what I'm going to take out. When I take 2x out of 8x squared, I'm left with 4x. And when I take 2x out of 2xy, I just have the y left over. 28 and 7 both have 7, so I'm going to end up taking out a plus 7. But x, y, and y squared both have a y. So the same thing happens, right? We're taking out variables, and that's okay. You can take out variables. That's fine. It happened. It just happened. 28xy, if we take out 7y, we end up with 4x. And if we take 7y out of 7y squared, we end up with plus y. The insides do match. If for some reason they didn't match, you did something wrong. You should go back and fix it. And then the outsides give us the other factor. And that's it. That's how you factor when a is not 1. Have a great day.